So we are on section 8.5, and we're still working with similar triangles. So we're going to talk about 3 theorems today. And again, I want you to get in your head that in similar triangles, the angles are congruent and the sides are proportionate, okay? So the first theorem is called the side splitter theorem. And this only happens if a line is parallel to a side of the triangle. So for example, if BE happens to be parallel to CD, if that happens, then it will divide the sides proportionately. So what that means, so again, if BE is parallel to CD, then the little chunk from A to B over B to C will be equal to from A to E and from E to D. Okay, so this will happen. So for example, I don't know, let's just say if this is 3 and this is 4, hypothetically then, this is 6, this would have to be 8. So if you actually matched up the proportions, so this little piece over this little piece, that proportion has to equal that other proportion. So that 3 over 4 has to be the same as that 6 over 8. I don't know why this is that color. There we go. Okay, so this will be true if the lines are parallel. If the lines are parallel, it splits the sides proportionately. That's the side splitter. Same thing, this is like a souped up version of that. So if 3 or more parallel lines are intersected by transversals, then the parallel lines divide them proportionately. Once again, if this is 2 and this is 3 and this is 4, this then would have to be 6. And of course, the only reason that this is working is if you know that these lines are parallel. So if these lines are stated to be parallel, then it will split the sides proportionately. So I have an example down here that I wanted to go through with you. So if you take a look at this, we have little chunks. So I have this little blue chunk is 3, the little pink piece is 2. Of course, it's not drawn to scale because we know my drawing. And then this orange piece is 5, okay? The given information is that from A to D, so this green segment right here is going to be 27. So this entire green piece is 27. And it wants us to find AD. So of course I'm going to fill in AB, sorry, find AB. I'm going to fill that in as an X. So we could do this one of 2 ways. We could take a look at each piece and try and find each piece, given that that's 27. Or what I can do is I can just add all of these up together. So I know that this entire, the blue, the pink, and the orange together is 10. So this segment right here is 10. This segment over here is 27, and because these lines are parallel, which I'm telling you I promise they are, because the lines are parallel, it divides these chunks into proportionate segments. So a couple different ways. Some of you guys like to use scale factors. So how did you get from 10 to 27? That's the same thing we did to go from 3 to X. So again, how did you get from 10 to 27? You have to do the same thing to get from 3 to X. That's called using a scale factor. I personally will set up a proportion every time. So the whole segment on the left side is 10. The whole segment on the right side is 27. The little blue piece on the left side is 3, and the little blue piece on the right side is X. That's what I'm looking for. So this is personally how I like to set mine up. Again, I take a look at this whole segment right here is 10. This whole segment right here is 27. This little piece right here is 3, and this little piece right here is X, okay? And again, this is like a souped up side splitter theorem. It only works if the lines are parallel. And from here, you guys, if you want, you can go ahead and cross multiply. So 10 times X is 10X. 3 times 20 is 60. 3 times 7 is 21. 60 and 21 is 81. And when you divide by 10, you have x is 8.1, which makes sense. It should be a little bit bigger, obviously. So that is, again, just the side splitters theorem. When the lines are parallel, that's what all of these say. When the lines are parallel, it is splitting the sides proportionately, okay? Our last theorem right here, it's called the angle bisector theorem. It's, again, very simple. If a ray bisects an angle of a triangle, so if AC is bisecting angle BAD, in other words, if this chunk of the angle is equal to this chunk of the angle, what happens is they discovered that the sides that it's splitting up end up being proportionate. So it splits it, I look at it like two triangles. I have the left triangle that's in pink and then the right triangle that's in blue. And you can see that these sections are exactly proportionate. So if I looked at the 4 and the 2, and I did 4 over 2, and I look at these sides over here as 10 over 5, you can see that both of these chunks are proportionate to each other. That's all that it's saying, okay? So when you bisect an angle of a triangle, the segments end up being proportionate to each other, okay? So taking a look at this, I'm going to do 2 examples with you guys for this. So the first example is telling me that JK is 10, and if you want to pause the video and try these yourself and see if you get the right answer, that would be a very lovely idea. If JL is 15, if ML is 12, and it's asking us to find KM. Again, I'm looking at this information and seeing that because this angle is getting bisected, it cuts it into 2 kind of equal parts here. So the left side is going to be proportionate to my right side. And I love proportion, so I'm just going to write myself a nice proportion. So 10 over x is going to have to equal 15 over 12. And again, I wouldn't work with 15 over 12. Let's go ahead and reduce that. Each of those are divisible by 3, to 5 over 4. And then from here, you can easily solve the proportion. X is obviously 8. If you don't believe me, you can go ahead and cross multiply, but I know that to get from 5 to 10, I'd have to multiply by 2. So to get from 4, this has to be 8 in order for those to be equivalent fractions. So I have my answer as 8, okay? If you don't believe me, go ahead and cross multiply, I promise. So we're going to do the second example. And again, if you want to go ahead and pause it and try this example for yourself. But we're working with the same given information. So, of course, hey, we have an angle that is bisected in a triangle. Therefore, the sides that it's leaving behind are proportionate. So we know that, oh, this is different. This is telling me that KL, this whole thing is 24. Okay. And then it's telling me that JL is 20. So 20. JK is 12, and it's asking for KM. So I always put that as an X because that's what I'm looking for. I need this other blue side, and I know that if that's X, that this missing blue side is going to be 24 minus X, whatever that is. If X is 10, that's 24 minus 10. If X is 7, it's 24 minus 7. So I just filled that in. And then again, we're going to go ahead and write our proportion. So 12 over X, the 2 pink sides have to be proportionate to those blue sides over there. And then again, I'm going to go ahead and cross multiply this one so you guys can see what this looks like. So we have 20 times X is 20X. When I cross multiply going this way, you have to make sure that you're multiplying 12 by the 24 minus X. Okay, so you're multiplying 12 by both of those. I like to do my math fast, so you guys can go ahead and do this and make sure you get the same answer as me, but I am going to divide out, let's see, a 4. So I'm changing this to 5x, and then I'm going to change this. If I divide this by 4, I'll get 3. Okay, so I'm going to go ahead and do this problem. These 2 problems are equivalent to each other. I just divided both sides by 4, and it's a lot easier to do, so I like to do easy math. 3 times 24, so 3 times 25 is 75. So I only have 24 threes, so 25 threes is 75, so 24 threes has to be 72. And don't forget to distribute the 3 to this x here. We're going to add 3x to both sides. And then you guys are going to go ahead and divide, and you get x is equal to 9. Okay, go back. Km should be 9 for our missing side length for Km. And that's it. So again, if you have an angle that's bisected, it splits those chunks into proportionate chunks. And same with the side splitter theorem. If you have parallel lines, then those sections, those little chunks are proportionate to each other.